Hi everyone. Today we're going to continue our lessons on logic, which is our Unit A. You should have your Unit A notes packet out in front of you. Okay, these slides can be found in there. And now we're going to start talking about how to use those conditional statements we were working with last week to make sound logical conclusions. And a lot of people want to try to do this just on instinct. It's a little more mathematical than that. There are actual rules for how you use an if-then statement to make a conclusion. And that's what we're learning today, are the laws of logic. So the first law of logic is called the law of detachment. And if you read it in words, it sounds a little confusing, but we've actually already talked about the law of detachment. Law of detachment says that anytime you have a true conditional statement, okay, so a P implies Q, if you have a situation where the P part is true, where the proposition is true, then the conclusion has to be true, okay? So if I say, oh, if it is raining outside, then I must carry my umbrella. That means anytime it is raining, I will be carrying my umbrella, okay? So if I tell you it's raining, you can conclude that I will be carrying my umbrella. So it's really a very basic law, okay? Let's look at a more mathematical example. So the example here, if two segments are congruent, then the segments have the same length. And I find it useful to sort of diagram this sentence out. So if the segments are congruent, then they have the same length. And helpful to write that down. So please do that for me. If the segments are congruent, then they have the same length. Okay, now I'm given this piece of information here. I'm given that I have two segments that are congruent. Well, that's a case of the proposition being true or the hypothesis being true. So I can follow the arrow here and conclude that AB and XY have the same length. Have same length. See how that works? That if I give you information that fits the proposition, where the first part of the sentence is true, then you can follow the arrow and conclude this part. You can't go the other way. Now this is a bad example of that because this could technically be written as a biconditional, where it could go the other way. But let's look at an example where going the opposite direction wouldn't work. Okay? And this is the biggest mistake people make with the law of detachment. In order for the law of detachment to work, you must be working with a case of the hypothesis or the antecedent or the proposition or whatever you want to call it. The if part has to be true. Okay? So look at this sentence. If two angles are vertical angles, then they are congruent. So again, I'm going to diagram out what that looks like. If I have two angles that are vertical, if I have vertical angles, I know they are congruent. Okay? Now let's suppose I tell you, here are two angles, A and B, that are congruent. Do you see that angle A and angle B being congruent is actually the conclusion of the statement? So I cannot go backwards and say, oh, they must be vertical angles, okay? And I see a lot of people do that. A lot of people make the conclusion, oh, they must be vertical angles. That's not a valid conclusion. Okay? So, again, this sentence is saying anytime you have vertical angles, they have to be congruent. But that doesn't mean that all congruent angles have to be vertical angles. All right, you can't go the other direction. You can't go against the arrow with the law of detachment. All right. And we've talked about this before. I'm trying to think of some of the examples we did last week. I'm thinking about the one in the perfume and the dance. If you go to the dance, then you get perfume. But if you have the perfume, that doesn't necessarily mean you went to the dance. Okay, that was one of the examples from the homework last week. Because you can't go backwards against the arrow with an if-then statement. The law of transitivity is another law that we're going to talk about, another law of logic. And if you've ever worked with the transitive property, which I'm pretty sure you've encountered at some time in your life, transitivity basically means you can jump from one thing to another, okay? And so for logic, what that means is if you have one conditional, P implies Q, okay, and then you have another conditional that starts with Q and makes another conclusion, Q implies R, then you can jump all the way from P to R and make one big statement out of that. And you'll see what I mean when we go through one of these. So here's an example. If a team wins 10 games, they get to play in the finals. If a team plays in the finals, they get to travel to Boston. Okay, so if I win 10 games, then I go to the finals, and if I go to the finals, then I go to Boston. Okay, so there are a couple of conditional statements for you. Now let's suppose that the Ravens won 10 games. And I'm going to take a quick second and diagram these out because, again, I think that's an important step in these problems. So if I win 10 games, then I get to go to the finals. By the way, you should be writing this down too. And if I go to the finals, then I get to travel to Boston. See how I can combine those into one statement? Because my second sentence started here. It started with the finals, so I can turn that into another conditional and say if I go to the finals, then I get to go to Boston. So if I am told that the Ravens won 10 games, well, I know that the Ravens get to go to the finals, but then I also know that they get to travel to Boston. And you want to make sort of the final conclusion. What is the end statement going to say? So therefore, the Ravens will travel to Boston. Okay, that's what the law of transitivity says. But again, you've got to be careful about the order of your statements, okay? You've got to have your second statement start at the conclusion of the first statement, all right? And you're going to see an example of in a minute of what happens when that doesn't work the way it's supposed to. So, if you look at this cartoon, penguins are black and white. So if I diagram that, penguins are black and white. Old TV shows are black and white. And then this cartoon is saying, therefore, penguins must be old TV shows. But do you see how these two statements both have the same conclusion? But it's not like I'm picking up from this conclusion and making a new statement, okay? I can't go from here to here and then go back this way because then I'm going against this arrow, okay? Oh, that's a bad color. I can't go this way against that arrow. That's not allowed. So be careful with your law of transitivity and what conclusions you're making. All right, let's hit some examples and then we are done for the day. So if you leave your headlights on overnight, your car battery will drain. There's that first sentence. If you leave your headlights on, you're not going to have battery the next morning. If your car battery drains, your car might not start. So starting from the no battery, I can add car might not start. Okay? And then it tells me that Alex left his headlights on. So let's find where Alex would fall in this statement. Alex is here. He left his headlights on. So we know that his car battery will drain. Therefore, his car might not start in the morning. That's our conclusion that we can make, that Alex's car might not start. And it says might, so we don't know for sure, but that's the conclusion we can draw. Okay, next one. If you multiply the length and the width of the rectangle, you will find the area. So, if I was going to diagram that out, if I have the length and the width, then I know I can multiply to find area. Okay? So length and width multiply to find area. So then it tells me that I have a length and a width. Here's a length, here's a width, so I'm living over here. All right, I have my length and my width. So what can I do? I can multiply to find the area. So I can do 5 times 6 is 30, and that's my area. That's my conclusion. Okay, let's look at this next one. If you want to be popular, you must dress well. If you dress well, you must wear brand X jeans. Well, really in this one, the only conclusion I can make is one big if-then sentence. Okay, and sometimes that's all you can do as far as a conclusion goes. So I'm going to diagram out the first sentence. So here is that first sentence. If you are popular, then you dress well. And then my second sentence starts with if you dress well. So right from the end of that, I'm going to put in that you're going to wear brand X jeans. Okay? And again, all I can really do with this one, because it doesn't say now, hey, Sally is popular, therefore, blah, blah, blah. I'm just going to write this as one big if-then from the original proposition to the final implication. So my conclusion for this one would look like this. Kind of a tough one to cram in there, so I shrunk it up a little bit. But if you want to be popular, then you will wear brand X jeans. That's really your conclusion, is that one big culminating if-then sentence. Okay, one more really important example here. If a person goes to the circus, then they will see clowns. Okay, so if I go to the circus, I know I will see clowns. So now let's think about what we can conclude, okay? Because it says Sally sees clowns. So do we know that Sally went to the circus for sure? Well, let's think about where Sally would be in my sentence. Sally is here. Sally is seeing clowns. Do we know she went to the circus? Okay. Correct answer here is no. I don't know that she went to the circus. No conclusion. Maybe she is seeing clowns at a parade. Maybe she is seeing clowns in her nightmares. Maybe she is seeing clowns in her head. I don't know. But just because she sees clowns, we don't know for sure that she went to the circus, because that goes against the direction of our conditional. So that last one is no conclusion, and that is a possible outcome, is that you don't have a conclusion you can make. Okay, homework for tonight is a worksheet. It is in your homework packet, and I believe it is just called 11-1 worksheet, okay, or 11-1 homework. It is front and back, and all you are doing is problems just like these that we just went through. Okay, so it gives you some information, and then you are going to try to make a conclusion using one of your laws of logic. Okay, we will go over this tomorrow. Good luck.